There's this invisible force at work all around us, all the time. It's constantly stretching and shrinking our world, from the biggest bridges you drive over to the tiny little gadgets in your home. You've seen what it does every single day. You probably just didn't have a name for it. Okay, let's start with something we've all struggled with. You've got that one jar in the fridge, right? And the lid is just completely, totally stuck. So what do? You run it under some hot water for a couple of seconds and pop, it opens right up. So what's the deal? What's the magic trick here? Well, it's not really magic at all, it's physics. The secret is something called thermal expansion, and it's a super fundamental property of, well, pretty much all matter. It just means that when you change something's temperature, you change its size. So with our stubborn jar, the hot water heated up the metal lid, causing it to expand just a tiny, tiny bit more than the glass did. That little bit of extra space was all it took to loosen its grip. Simple as that. So, if you're going to remember one thing from all this, it's this simple rule of thumb. Heat things up, they expand, they get bigger. Cool them down, they contract, they shrink. That's the core idea. But as you can probably guess, it's not quite that simple for everything. See, this simple rule, it plays out very differently depending on what we're talking about. Is it a solid, a liquid, a gas? Turns out, the state of matter completely changes the expansion game. So check this out. In a solid, all the little particles are packed together super tightly, kind of like a sold-out concert. So when you heat them up, they don't have much room to move. They only expand a little. In a liquid, things are a bit looser, so they expand more. But gases? Whoa. The particles are already so far apart, just floating around. You add a little heat, and they expand a huge amount. It really all just comes down to how much freedom those particles had to begin with. Okay, so this brings us to the next obvious question, right? We know heat makes things expand, but why? What is actually happening at a microscopic level that causes this? To get that, we need to zoom in. I mean, way, way in. So I want you to imagine that every single object, your desk, the water in your glass, the air you're breathing, is made of trillions and trillions of tiny particles. And these little guys, they are not just sitting still. Oh no, they are in a constant state of motion, a kind of frantic, microscopic particle dance. So here's how that dance works. Step one, you add heat. But what is heat really? It's just energy. So when you add that energy, the particles start to vibrate and dance way faster, way more violently. And as they're jiggling around, they start bumping into their neighbors, demanding more elbow room. They push each other further and further apart. Now imagine trillions of particles all doing that at the exact same time. And boom, the entire object gets bigger. Okay, so we've gone from a stubborn pickle jar all the way down to the atomic level. Pretty cool, right? So now let's zoom back out and see where this particle dance is happening in our world. Because sometimes it's incredibly useful, and other times it can be seriously destructive. Think about an old school thermometer. That's a perfect example of useful expansion. The liquid inside gets warm, it expands, and it has nowhere to go but up that tiny glass tube. But that exact same force can be a massive problem. On a really hot summer day, steel railway tracks can expand so much they actually buckle and warp right off the ground. This is why engineers are absolute masters of this principle. They even have a special number for every material. It's called the coefficient of thermal expansion that tells them exactly how much it's going to grow. That's how they know to put those little gaps in sidewalks. You've seen them, right? They're called expansion joints. They give the concrete a safe place to expand into so it doesn't crack itself to pieces. And that really is the biggest takeaway here. This isn't just some quirky thing you learn in a science class. It's a powerful, invisible force that's working at every single scale you can imagine, from the tiny vibration of one atom all the way up to a massive bridge that literally grows and shrinks with the seasons. Thermal expansion is always, always at work. So the next time you hear your house creak and groan on a hot day, or you look up and see the power lines sagging a little lower in the summer than they do in the winter, you'll know exactly what's happening. You'll be seeing that particle dance in action, live. Now that you're in on the secret, where are you going to spot it next?